morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about question bank discussion on color image processing. So, first question, give the properties of pseudo color image processing. There are actually two major areas are there in the color image processing. First one is a full color processing, another one is a pseudo color processing. So, these are two types. Two types are belongs to color image processing. These are belongs to color image processing. So, in the two major areas are there, full color processing, pseudo color processing. Full color processing, the images are acquired with a full color sensor, that is a color TV camera or color scanner. Another one is a pseudo color processing. So, pseudo color images are generated by assigning a shade of color to a monochrome intensity or range of intensities. Approaches for assigning color to monochrome images based on properties of gray level content. So, pseudo color processing is a technique that maps each of gray levels of a black and white images into a assigned colors. So, what are the two major types of colors are there? Full color processing, pseudo color processing. So, these are also called true color processing and false color processing. So, true color means full color, false color means pseudo color, means it is not original. We have to change the intensity values from the original, that is a false color. So, in the full color processing, the images acquired with a full color sensor, that is a color TV camera or color scanner. In the pseudo color processing, the images are generated by assigning a shade of color to a monochrome intensity or range of intensities. The approaches for assigning color to monochrome images based on properties of gray level content. And the pseudo color processing is a technique that maps each of the gray levels of black and white images into an assigned color. These color images, when displayed, can make the identification of certain features easier for the observer. The mapping are computationally simple and fast. So, what are the discussing of two types are there? In these two types, first one is a true color, second one is called false color. But these are all very important for the image color processing. These colors are displayed to make a identification of certain features easier for the observer. The mappings are computationally simple and fast. And the monochrome images, the term monochrome is usually taken to the mean the same black and white and more likely grayscale. But any of the color is used to refer to other combinations containing only tones of a single color, such as green and white or green and red, like this. These three approaches are intensity slicing and color coding, gray level to color transformation, filtering approaches. So, these are the three major approaches are there. So, beyond this full color image processing and pseudo color image processing, another one is a monochrome image processing. So, what is the role of monochrome image in the color processing? So, the term monochrome is usually taken to the mean of the black and white, that means a gray or more likely grayscale, but may also be used to refer other combinations containing only tones of a single color, such as green and white or green and red colors. So, these three approaches are intensity slicing color coding, gray level to color transformation, filtering approach. Okay, these are the three major roles are monochrome images. And the main two categories of color image is a pseudo color, that is a false color, and a full color image, that is called true color. So, true color is also called full color. And then one is a false color, that is a pseudo color image processing. So, in the true color, original image should be available. Here, changing the intensity values. not an original image. So in the true color versus false color, the true colors are images with a natural color rendition. A red apple appears a red, blue ocean appears blue, etc. It's difficult to achieve absolute true color in images, but being approximately close to human perception is acceptable. Another one is a false color images. On the other hand, sacrifices natural color rendition in order to facilitate the detection of some objects. They are mainly used for satellite and space images. So true color means we can't change any modifications or anything. It is a natural colors. Suppose red apple appears as a red, blue ocean appears as a blue. So it is difficult to change or achieve absolute true color in images. We can't change it because the originality will be missing. In the false color means unidentified images are there. We have to go for the identifying. Suppose satellite images, space images are there. Those are original, but as per human visibility, it is difficult to see the images. So that is the reason we are changing the intensity values. That is, we are sacrificing the natural color rendition to order the facilitate the detection of some objects. That is a false color. And pseudo color images are originally grayscale, but assigning colors based on the intensity values. Typical usage of these images are the thermography, where the only available is infrared radiation instead of lights. Another example is a elevation map. Actually, it is a NASA captured image. It is the input, but visibly visibility is not appeared. So what we have to do? We have to change some modifications or the intensities are there. We can see here these are visibly is not good. Actually, it is an original image NASA, but we can't see as per human visibility system. It is typical to see the image. So it is an example of pseudo color image. But the original grayscale, which are assigned colors based on the intensity values. Typical usage of these images for thermography, where the only available infrared radiation instead of lights. Another example is a elevation map. So like this. And intensity slicing. It is a simple case of pseudo color image processing. It is also called density slicing or color coding. So the grayscale images are the 3D function with the intensity being the third dimension. Placing a plane parallel to the horizontal plane for the pixel position coordinates would slice the image into two parts. After that, we can assign different colors to different levels. So this intensity slicing is a simple case of pseudo color image processing. It is also called density slicing or color coding. So, so the grayscale image as a 3D function with the intensity being the third dimension. Place a plane parallel to the horizontal plane, but the pixel position coordinates would slice the image into two parts. After then, we can assign different colors to the different levels. So, it is an example for geometric interpretation of the intensity slicing technique. So, we are taking as a 3D x, y, z coordinates. So in the x coordinate, I am taking as a 0, white, black, and slicing plane. So white, black, and slicing plane. So what are the coordinates are there? It is a 3D coordinate. So we have to easily find out what is the intensity of that one. Okay. And we are not constrained to use the only one plane. Multiple slices of result is more flexible representations of the grayscale image. In this case, the grayscale is plotted into intervals of each one is assigned to a different color. Here, input is a gray color. But I have to go for the color image with segmentations. So it is a constant to use only one plane, multiple slices for flexible representation of the grayscale images. But these grayscale are parted into intervals of each one is assigned to a different color images. But the density slicing is a 8 colors are there. Demonstrate the basic full color image processing in color image processing. There are two approaches are there. Approach 1. The process of each component image individually then form a composite processed color image from the individually processed components, and that work with color pixels directly in full color images. the color pixels are really a vector. In the RGB system, each color pixel can be expressed. So, what are the two approaches are there for the full color image processing? Each component of the image individually and then form a composite processed color image from the individual processed component. And the another one is a color pixel directly in full color image, and the color pixels are really a vector. In RGB system, each color pixel can be expressed. So C of x comma y. So C is a pseudo color. It is a color combinations, but RGB is a original. So here it is a combinations. It is nothing but a secondary. These are the primary colors. So primary means R of x comma y, G of x comma y, B of x comma y. RGB, red, green, and blue. So we came from secondary to primary. The M of n is a size, and vectors are C of x comma y equal to x equal to 0, 1, 2, so on m minus 1. Here neighborhood averaging is a spatial mask of gray level to RGB colors. Here input is a input image, that is a grayscale. So grayscale to full color, it is a neighborhood averaging of the spatial mask of grayscale to RGB color. And what is the formulation for grayscale to color image processing is that the model color transformation is G of x comma y equal to capital T of f of x comma y. The pixel values here are the triple or quarters. Analog to section gray level, we know the consider SI equal to TA of this one. So G of x comma y is the output. T is equal to transformation function. F of x comma y equal to input image, output function. So G of x comma equal to capital T of f of x comma y. Grayscale to color image processing. So summarize the color transformation with examples in color image processing. It is useful to think of a color image as a vector valued image where each pixel has associated with it as vector of 3 values. Each component of this vector corresponds to a different aspect of color depending on the color model being used. For example, in the RGB model, the 3 values in the vector respectively denote the red, green and blue components of the color of the pixel. And in the HSM model, the 3 values in the vector denote the hue, saturation and intensity of the color of the pixel. So, what is the question is that summarize the color transformation with example in the color image processing. In the what is a color transformation? Which type of transformation you are using in the color? So it is useful to think a color image of the vector. Each pixel associated with it, the 3 values, each component of this vector corresponds to different aspects. For example, I am taking the red, green and blue. So this RGB color, the vector respectively denote the red, green and blue components of the color. But the HSI, that means we are going for the hue, saturation and intensity. So this RGB we are converting to this type, that is the hue, saturation and intensity values. But we can think the color transformation is a transformation vector SI equal to TA of R1, R2, R3. Here R1, R2, R3 represents the color components of the input image f of m, n. S1, S2, S3 represents the color components of the output image G of m, n. In the theory, any color transformation can be performed any color space model. In practice, some transformations are better suited to specific models. Moreover, cost of conversion between the models must be factored implementation of particular transformation. So, in the color transformation technique, what is a transformation equal to SI equal to TA of R1, R2, R3. Here I equal to 1, 2, 3. So, R1, R2, R3 are the input function, SI equal to output function, and TA is the transformation function. In practice, the transformations are better suited to specific models and the conversation between the models must be factor implementation of a particular transformation. So here, example of color histogram equalization, RGB, red, green, blue to this one. So it is a input function, it is a output function. So RGB to HSV, hue, saturation and intensity. FH of M is a transformation function. Here HSV to RGB, input to output, same. Here histogram is there. It is an example of histogram equalization. It is the original image, that is the input, and it is the output, that is a histogram equalization. So what is means, we changed the some intensity values, that is a background. It is not visible in that, so dull in the image. Out the output side, the colors are changed, background is there, and we are identifying easily the image. That is a histogram equalization. It is another example of histogram equalization followed by saturation adjustment in the HSA color. HSA means hue, saturation and intensity. So histogram equalization followed by saturation adjustment in the HSA color space. It is a H, hue, saturation and it is the intensity. So it is a histogram equalization of combination of H, S and I. So these are the references about the color image transformations. So in the exam they given, they are asked what are the pseudo color image processing are there. But before going to the pseudo color image processing, we have to discuss about what are the two major colors are there: full color image processing, pseudo color image processing. So full color is the true color. It is also called true color. These images are acquired with a full color sensor. Pseudo color images are generated by the assigning a shade of color to a monochrome intensity or range of intensities. The approaches are assigning color to a monochrome image based on the properties of gray level content. Pseudo color processing is a technique that maps each of the gray level of a black and white image into a assigning black. That is a pseudo color. And these colors are displayed can make the identification of certain features easier for the observer. The mappings are computationally simple and fast, but the monochrome images are usually taken to mean the same as black and white and likely grayscale, but may also be used to refer other combinations containing only tones of a single color, such as green and white or green and red. Thus, three approaches are intensity slicing and color coding, gray level to color transformation, filtering approaches. And two main categories are there: pseudo color or false color image processing, full color image processing, or true color image processing. So what is true color versus false color? There are two main categories are there. So true colors are images with natural color, red apple or blue ocean, etc. These are the true colors. Okay, it is difficult to achieve absolute colors, but being approximately close to human perception is acceptable. It is a good. But false color means we are removing or we are adding or we are changing the original. True colors means changing the true colors. That is called false colors. That is called false colors. So on the other hand, sacrifice natural color rendition in order to facilitate the reduction of some objects. They are mainly used for satellite and space images. Pseudo color images are originally grayscale, which are assigned colors based on intensity values. Typical usage of these images as for the thermography, where the only variable is infrared radiation instead of lights. Another example is elevation map. So actually it is a NASA captured input value, but it is visibly difficult, is not appeared. So need to change the intensities or color values. So intensity slicing is a simple case of pseudo color image processing. It is also called density slicing or color coding. In the grayscale image is a 3D function with intensity being a third dimension, placing plane parallel to the horizontal plane. The pixel position coordinates would be slice the image into two parts, after can assigning different colors to different levels. It is one example of slicing plane of 3D x and y z coordinates with intensity axis. And here we are not constraining use only the plane multiple slicing, result in a more flexible representation. But the grayscale is plotted into intervals of each one is assigned into a different color. So input gray color is converted into the color image. So gray is converted into the color image with adding red, green and blue colors. Demonstrate the basics of full color image processing in image color processing. There are two approaches are there. Approach one, to process each component image individually and then form a composite process of color image from the individually processed components. Approach 2, with the color pixels directly. In full color images, color pixels really are vectors. In the RGB system, red, green and blue. Each color pixel can be expressed as C of x, equal to CR of x, y, CG of x, y, CB of x, equal to R of x, y, G of x, y, B of x, y. Here, another two-dimension size and vectors is equal to C of x, y for x equal to 0 to 1, so on, n minus 1, y equal to 0, 1, 2, so on, n minus 1. So, it is a spatial mask for grayscale and RGB color images. So, spatial mask to color image. The formation of color model in that G of x, equal to capital T of f of x, y. So here grayscale conversion to the color image, G of x, equal to output, it is a transformation function or histogram process, f of x, is the input function. So summarize the color transformation with example in color image processing. It is useful to think of a color image to a vectored value image where each pixel has associated with it and vector of three values. Each component of this vector corresponds to a different aspect of color depending on the color model being used. For example, in RGB color, the three values in the vector respectively denote the red, green and blue components of the color of the pixel. But in the HSA model, the three values in the vector denote the hue, saturation and intensity of the color of the pixel. We can think that the color transformation as a transformation of vector Si equal to Ta of R1, R2, R3. Here Si is the output function, R1, R2, R3 are the input functions, T is the transformation function. And the transformations are better suited for specific models. In the converse way, in the conservation between the model must be factor implementation of a particular transformation. Here RGB to HSV, here RGB to RGB is there, G of m, F of m, input function equal to output function. But meanwhile, what is happening is applied. So what is the transformation function means? We are using some histogram, Fourier transform, Laplace transform, fast Fourier transform. All those things are the transformation functions. It is the example of histogram equalization. It is the original image. The background is we are not visible like good image. When I am going to the output, that is a histogram equalization. What is means we are after changing the intensity values from the input image. So it is called a histogram output. It is figure A and figure B. Here histogram equalization followed by hue, saturation and intensity. Here it is a hue. It is a saturation. Used hue method, here saturation, here I am applied the intensity. So figure A, figure B and figure C are the HSA, hue, saturation and intensity color space. So these are the references of these things. So here we discussed here majorly summarize the color transformation with example in color image processing, and we discussed about the histogram here, and here demonstrate the basic full color image processing. In the we discussed two approaches of full color, that is a secondary color to the primary color to the secondary color with the suitable vector function. It is a spatial mask to the grayscale RGB. Here that is a question is a demonstrator. Another question here is the intensity slicing. What are the two main categories of color image processing? Is a pseudo color image processing. Another one is a full color image processing. It is also called true color versus false color. So the question is the give the properties of pseudo color image processing. Two major areas: full color or true color, pseudo color or false color. Okay, these are the two main categories. Pseudo color image processing. It is a density slicing or color coding. It is a block diagram of geometric interpretation of the intensity slicing technique with it is a one segmentation. It is a y coordinate, x coordinate, and z coordinate. It is a x, y, z coordinate. But here f of x comma y function with the intensity axis from 0 to L minus 1. Okay, completely it is white, completely it is black, like this. It is a combination of white and black. So it is a black and white color segmentation with red, green, blue intensities. Here there are two approaches for color image processing from the normal color. Okay, this is the formation and the transformation function using for color image processing. Okay, it is a histogram process, and it is the hue, saturation, and intensity HSA color. So RGB to HSA. It is one method of RGB to HSA. Hue, saturation, intensity. Red, green, blue to hue, saturation, and intensity. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.